That's mission mode. The rule set that I play KSP by is to teach people lessons about the space program and how you go about engineering it. That's the whole point. And once again, I can't give myself a pass. I can't listen to the rules when it's convenient for me and then ignore them when it's inconvenient for me. You know, or ignore them when it's convenient for me. Then why did I make the rules? I have to adhere to the rules, and I have to stay true to that, or else mission mode is worthless as a teaching tool. So I got to take the lick, dude. It is what it is. I'll figure out another way around it. We're smart. But yeah, guys, you know, just on a side note, I won't take a break. I'm not really hungry. We'll get that payload up and launched after Space News. Space News is going to have a hard stop at 6 o'clock. Yeah, Kerbal will resume in about an hour and a half. But yeah, I just want to say that I'm sorry about yesterday. That's not okay. I can't do that. It's gross. It's disgusting. So an 8,000-hour airline pilot still uses checklist. Yeah, that's true. That's true. Yeah, Chief, I appreciate that, but on the other hand, talk is cheap. So I'm going to prove it to you by launching the SSTO today and getting back right on the horse, so to speak, or SSTO. So, Seid für Weltraumnachrichten. I don't know what that means, but alright. Also, don't worry about that viewer. If that viewer's around for long... Well, Devious, that guy's been watching for a long time. I do keep track of that. Not on purpose, but... The worst thing isn't you getting mad, but everyone else in chat... Well, Sebi, here's the thing. If I get pissy, chat's gonna get pissy. If I'm happy, chat's happy. If I'm having a good time, if I'm joking around, chat's joking around. Look, I have a theory about streaming. The theory is that chat is a reflection of me. And I'm a reflection of you guys. People only watch streams where they identify with the streamer, right? That's what makes people watch the stream. So in reality, I'm looking in the mirror, all right? If I get mad, you're going to get mad. If I get pissy, you're going to get pissy. If I say this, you know, this is bad space news, people are going to get mad. People get pissy in chat and they start arguing over semantics. It's my fault. I'm the one that's setting the tone here. And as the kind of leader of this, because it's my stream, I have to be an adult about this. I can't be cursing out frigging viewers, man. That's so unprofessional. It's disgusting. And I'm ashamed. Like, it's frigging gross. I'm ashamed in myself. It's disgusting. I can't even, like, find the words to articulate how disgusted I am with myself. Hey, Jam, 77-month resub. Are you saying you influence people? Yeah. Yeah, Draco, exactly. See what I mean? It's not that guy's fault. It's not, you know, like that's... It's not his fault. You know? He was just looking out for me, and I understand. And I tried to write him an apology. I said, hey, I'm like right after. I'm like, dude, I shouldn't have done that. I'm such an idiot. I never got a response. So that's the best I can do. Like I said, man, if you curse out viewers, they're probably not coming back. Get over it and move on. Pretty much. Making apology videos. Damn, you're an influencer. Yeah, apology videos. Yeah, but talk is cheap as hell, man. Talk is cheap as hell. You know, there's one thing apologizing, but do you ever notice in those... Dude, you ever notice in those apology videos how they never take responsibility for their own actions? Ever. Nobody ever does that. Nobody ever admits to any wrongdoing in those videos. I hate those damn things. Right? They always freaking go, oh yeah, you know, what I did was not okay, blah, blah, blah. I'm going to learn from this experience. Yeah, shut up. You're going to learn from this experience. Yeah, okay. I'm telling you straight up, what I did was wrong. That was incorrect, and that's not how you run a stream, and it's unprofessional, and I'm going to freaking fix it. That's it. You literally just said the same thing, though. Yeah. Whatever. I'd like to think there's a differentiation there, but it's all right. We're going to launch it on the other side of Space News, Pilch. Yeah, not to mention apology videos are good for business. I don't make any money off sitting here apologizing to you guys, that's for sure. I could get more viewers going and launching the SSTO, but it made it... Look, a lot of you guys have been with me for a long time. I owe it to you to tell you what's going on. That's very, very important to me, at least. Do I have the SPAC links? Yeah, I got most of them. Yeah, I have them. Mm-hmm. Cygnus hat, yep. Yep. Yeah, Nighthound. That's pretty much it. It's not sincere. And it's very easy to say because they never admit it. Seriously, go watch an apology video. They never frigging admit what they're doing. They explain their actions and they explain their actions was wrong, but they never admit that they were wrong. Okay? It's annoying. I really don't like that. Take responsibility for your damn actions. To be honest, I don't think you're actually in the wrong. You get to decide how it operates on your stream, and while you may think it's wrong, for me, if I'm being dumb, you have the right to curse me out. King, that doesn't get more people involved in space, man. Eyes on the prize, dude. Eyes on the end goal. It's not about me. It's about space. That's my rule. I'm just some guy. I'm just an intermediary for you guys to learn about space. That's it. But anyway, talk is cheap. Let's go. Since you're a fan of ugly planes, I thought you would like to see this. Oh, Tacit Blue. Yeah. My girlfriend did not approve of the idea to get a Cygnus hat. All right. The other guy was projecting on you, was annoyed by it. Yeah, hey, Corn, hey, it is what it is, man. See, that's what I mean. If I'm pissy, everybody else is gonna get pissy. If I'm taking it out on viewers, people are gonna take it out on viewers. It's a weird phenomenon that I've noticed. I can't do that. I can't do that. I can't claim to be a professional teacher and communicator of space news and do that. That's disgusting. Anyway, let's go. Space news. I'll be back in a second. Let me just put the title card up for a moment, and I'm not going anywhere. I'm just gonna play one song so people can see it in the VOD. All right, dudes. Let's roll. Let's roll. Time for space news. Oh wait, I got no. Wait. We gotta have the intro music, obviously. Autobots, roll out. What is this? Oh, Elon's in Italy. Neat. Man, he was in like Texas like a second ago. Do we have much space news? It doesn't matter, Chief. I'm stopping space news at 6 no matter what. So, yeah. I know there's no video, W. I was just looking at it on the side. Yeah, he starshipped over there. Yeah, obviously. All right, let's do some space news. So, Lavi, you, at the beginning of space news, what do we got here? You were working on your launch vehicle. Hey, LV6. I see what you did there. All right, what do you got? Yeah, okay. You don't need to put a strong back right there. The rocket can be the strong back when you're using this type of architecture, unless that bends on you. Space news. That's right. Okay. You're integrating payload and upper stage at the same time. All right. Oh. Okay. All right, I see what you're doing. Yeah, okay. I see what you did there. Oh, you went for a free-floating design. Okay. Okay. You're gonna have some bending issues here, unless you're using auto struts, in which case you're not. But this is a complicated separation sequence right there. And then you have hold downs on the outer boosters too. Okay, all right, I see what you're doing. So Lavi, couple tips. You only need one docking port for a side booster. You don't need two. I mean, you could, but you're going to need a cow controller to sequence the ignition with these things, or else it's not going to work correctly. I ran into that problem with the space shuttle. But other than that, this looks good. And you said you had integration. You said you had an integration thing, an integration problem. Oh, your crane's bending. Wait, whoa. What's going on here? Yeah, you need the rails. You need the rails for the crane. Trust me on that one. The crane will drift. Look, oh, what the? Yeah, you're not plumb. That's not good. This stuff needs to be plumb. It's important when you dock things that you have to dock it. You dock it on the exact same heading as the thing you're docking to. So if your first stage is pointed straight up and your second stage needs to be, when it's hanging, needs the docking port on the bottom of the second stage needs to be pointing straight down. If those are incongruent, that'll bend the stack. Yeah. So that's what. So you said you integrated in your alignment is 88.2. Don't launch. Take it apart. I know it's a pain in the butt. Take it apart. Take it apart. Put it back together. Put it back together correctly. Yeah. You need rails for the crane, and this separation sequence is going to be a little complicated. You're going to need to sequence it with a cal controller because you have to tell it to undock all this stuff first. And you have to make sure when you put the booster together that you don't dock to the outer ports, or else your booster is going to dock to the pad and your center core is going to dock to the pad. And when you let the center core go, the boosters will stay on the pad. Docking port hierarchy rules. But hey, this is still good progress. You're getting there. Nice crane, by the way. All right, anyway. Let's start up with the space news here. The tolerance on stage 1, stage 2 is about 0.2 degrees. Okay? Did you watch part 3 of the interview? I did watch part 3. That's why I delayed the stream, Balksy. The stream started at around 1 because I woke up and I was getting ready to stream, and part 3, I realized part 3 came out, so I watched it. Part 3 doesn't have much information. There's a couple of things. That yellow structure is the quick disconnect for Starship, so it's Starship's propellant feed line. So it kind of confirms something that we already knew. We kind of already knew. I had once said at one point that Starship will be fueled through super heavy. It doesn't look like that is a thing right now. It could be subject to change down in the future. Which leads me to the second thing that we learned. Starship is in flux so ridiculously much that stuff changes on a day-to-day basis. So they change the design very, very fast because they say, oh, we built this umbilical, and this umbilical kind of doesn't work, so we need to figure out a better way to do it, so we're going to change it. We're going to change it to a side umbilical instead. They really do switch stuff up, and that video, amongst everything else, shows how fast they go. It shows how quickly they can get stuff done. It's really insane. Yeah, Sam's cool, yeah. Yeah, Sam, that guy's cool. Boxy, hearing him talking about flanges and launch pads, man, that was my favorite part of that video. So, in Tim's new video, he's talking with Elon, and Elon goes to the launch pad, and he starts talking to his Starship operations engineers. So there's this guy named Sam Patel, and he has a kick-butt Hawaiian t-shirt on. This guy looks like something out of Miami Vice. It's awesome, right? It's really cool. He starts talking to him, and they start talking about integrating the orbital launch table to the pad, and how some stuff is misaligned. Some flanges are misaligned, and they're using hydraulic jacks to level that pad before they put it on. Does that sound familiar? That sound familiar? How cool is that? That sounds familiar, doesn't it? You gotta level it. This is why I shared Lavi's thing first. Sam is the Starship Ops Director. Cool guy. He went to Embry-Riddle. Yep. Sam was the lead engineer for Slick 40 and 39A. Yep. Yeah. Sound familiar? See, dude, this is what I mean. Mission mode isn't an exact technical replica, but it demonstrates the points correctly. Misalignment is no good, and misalignment happens, even with something that big. If anything, it's compounded by the size. Pretty cool, huh? See, that's why I build these pads, man. I need to get an end-to-end reading. It helps me analyze what's going on with Starship a lot better. What did he mean when he said with 1-inch welds they get 40 miles an hour on the booster? I'm not sure what that means. With 1-inch welds he get 40 miles an hour on the booster. I'm not sure how that's correlated, Valk. I mean, J-Speed Sam might, for all I know, he might. 40 mile an hour impact tolerance? Yeah, maybe. I don't know. I'd have to go listen to it again. Increased welding mass is less delta V. Well, 4 miles an hour isn't a measurement for delta V. It's a velocity, and so delta V, spacecraft range is measured in velocity too. But I'm not sure exactly what he meant. I missed that part. But how they were talking about centering, they were using a centering gusset to get the table onto the. Oh God, that made me so happy. I'm like, oh man, they're using alignment jigs. I use those in Kerbal. Yes, you know. I'm like, yes, I do that too. Oh, that's so cool. Dude, I love that part. That was my favorite part of Tim's entire interview with Elon. Dude, I would pay a good amount of money just to have a camera following Elon Musk around when they're talking about Starship. I don't need him to be interviewed. I just need a camera following him around when he's on the job and them talking about, like, you know, putting brackets together. Like, dude, I would pay good money for that. That was my favorite. Also, using 2 cranes saved 4 days, which is so smart. Mm-hmm. Yeah, obviously with a microphone too. Mm-hmm. "40 miles an hour, they were probably referring to windage, Bauxy, with the cranes, but I'm not sure. Either way. Yeah, exactly, Bear. I think that's right. A 1-inch deep weld could secure the booster in up to 40-mile-an-hour winds. Yeah, and did you hear them talking about welding? I've told you guys about this, how you have to layer, when you're using big metal, like when you have thick metal, there's no welder on Earth that's strong enough to be able to pen like 10 centimeter thick or 100 mil thick steel. There's no way. So what you have to do is you have to lay welds in, and the distance between these things is it's really hard. If you have even a quarter of an inch distance, you can't lay bead in there. You can't lay welds. It'd take frigging forever to do that. So getting that orbital launch table to not bend and getting it so it's nice and level when they put it down is key to welding that thing and getting it to be secure. This is the exact stuff we talk about when we build launch pads. So, like, why alignment and why having the heading alignment indicator up is so ridiculously important. Even in Kerbal, it makes a big difference. It has to be plumb. Everything has to be level, or else you're going to go to launch the rocket and it'll do this off the pad. Or the SSTO when we went to launch it. When we went to launch it, the entire pad moved a little bit, and we launched the SSTO, and it went out a little sideways, and then when it tried to compensate, it blew the engines onto the launch box, and the engine exhaust went onto the launch box and cooked it. See what I'm talking about? That's really, really cool stuff. That's the stuff I'm super interested in. I love it. I could listen to that all day. Yeah, that's right, O-Force. Mm-hmm. Starship will have a GSE designed for Super Heavy. Starship will have shuttle GSEs for Super Heavy. Let's go. Yep. What if it's a hot plate? Then, yeah, we want to cook on the pad, Charadra. Rockets get hot, too. Got them. That must be automated welding. Didn't seem like automated welding to me, DNF, from the interview. Dude, you got industrial welders. Dude, industrial welders make so much money. I'm not talking like metal fabrication. I'm like talking about guys that build oil rigs and stuff. Build oil rigs, put ships together, build like skyscrapers. Those guys make tons. Dude, industrial welding is a freaking art. It's really difficult. Can we see the video again? Farfuggia, Timmy doesn't want other people showing his footage, and I understand that, and I get it. I'm not going to make a big deal out of it. So... yeah, I can't show the video, but yeah, it's Tim's interview with Elon. I want to be the crane operator, dude. Bauxy, the guy that's operating the 11350 makes more money than you and me and a lot of people in chat. Speaking of welders, Newport News is always looking for welders and willing to train from nothing. There you go. Well, some foods in the lunchbox may some food in the lunchbox that day might have need to be warmed up. Yeah. Anything on practical TPS issues? Nah, not really. Giant Waffle restreamed all of part 1 without permission. Yeah. I mean, Grav, I'll be honest. I could probably stream it, and I could probably get away with it. But I asked him, look, I do my due diligence with my fellow spaceflight content creators, all right? It's very important. That's very important to me. You know, like, don't get me wrong, you know, we could, if, you know, like, If I did that with everything, we wouldn't show like newscasts on stream sometimes, or we wouldn't even show launches. But I make sure to ask permission because I respect what Tim does. Honestly, I really respect what he does. He's doing a great service for us all, like getting this footage. I mean, he's the one that stepped up to the plate, and he did good, you know? It's really easy on stream for somebody to link a video, right? And it's a cool video and you want to watch it, and then you just pull it up on stream without even thinking about it, you know? Did you hear them talking about the welding that needed to be done? Yeah, goalie, isn't that cool? It's sick, man. So, look, I can't curb this thing completely, but with fellow spaceflight content creators like NASA Spaceflight, Timmy, Lab Padre, anybody else, I make sure that I go and ask. It's better to do that. And Tim said that he didn't want other people to see it, and that's fine. I get it, dude. Like, why would I do that? That's taking money away from him. That's lame. I'm literally making money off his work. That's stupid. I don't like that. I don't want to make my money that way. So I always ask for permission. Tim lost his private light because of Starship kinda bold. What do you mean, Forge? That's why if we're watching like a YouTube video, if I put Haze Gray up or Stratton Blitz or anybody, two things. I never watch the entire video, ever. Even space news articles, I skip over parts. I don't do that for my health. I do that on purpose. I skip over things. All right? I skip stuff because if you want to read the rest of the article, go and click the link. You know? Yep, that's right, Buck. We're helping, not hindering. Check Discord, but shh. Yeah, Lavi, that's nothing that I didn't know. Alright. I feel like he's the link between the space community and the industrial professional side of things. Yeah, I mean, he does a good job, Builder. Yeah, he does a good job. I wish I was that smart, dude. And don't get me wrong, I know the engineering, but the professional game part of it, like, you know, making contacts and stuff, like, I'm dog crap at, dude. I really suck. I'm really not that good at it. Don't know if you saw. I wasn't suggesting you should do it. I was more meaning I was disappointed he didn't ask. Oh, yeah, Grab. No, I know. See, like, that's the thing, dude. That's the thing that I've noticed. If you're big enough, people don't care. If you're a small streamer, like, if they think it's mutually beneficial, then it's fine. But if they don't, they'll be like, nah, don't do that. But I'm pretty sure Waffle can get away with it because he's Giant Waffle. I'm EJ. You know, it's all good. Kind of public info. Kind of public info from him. Oh, I didn't know that. That's a shame. That's... DJ Waffle Giant, that's it, yeah. Jeez, Forge. I didn't know that. That's, I mean, I appreciate the commitment, man, but holy crap, dude. But hey, then again, my first real serious relationship didn't go well. And I'm not saying that I'm totally in the clear here, you know, it didn't go well. And she ended up ultimatuming me and said me or the stream, and I said bye-bye. It was a little worse than that. But yeah, that's yeah, you got to make tough decisions, dude. That was not an easy one. You know, no one wants to be alone. That sucks. That's not fun. No one wants to be alone like that. Dude, I don't think I'd be able to do this as well as I can without Brimo backing me up. I'm serious. I'm 100% serious about that, dude. I might still be able to do it, but I wouldn't be able to do it to the extent that I do. Like quarantine streams is a good example. I would not have been able to do that if I was alone. There's no way. Well, Brimo, I mean, that proved to be a good decision. I found someone better. you know, I've obviously. I chose you guys. Well, yeah. Interesting grain geometry. I just bought. It's on both sides. Ooh. So what do you... That's a progressive thrust curve. No, that's not a progressive thrust curve. Cyborg, what kind of... Well, actually, let's take a look. You bought a new SRB. It's on both sides of all 4 grains just for a little extra kick off the pad. Oh, yep. I see it. The grain is cut. Yep. Progressive thrust curve. Or no, regressive, excuse me. Regressive. Your combustion chamber surface area is going down over time. Yeah, regressive thrust curve. It's neutral? Yeah, right. You can buy SRBs if you have the certifications to buy SRBs. Do not try to go find an SRB. Yes, you will get put on a list, and that's not me just saying like you get put on a list. No, you're dealing with ITAR stuff now. You need the certifications. You need to prove that you can handle it and you're not going to do anything stupid with it. Do you mean that super heavy will throttle down? We're not talking about super heavy. Swishio? Well, all rockets do that, Swishio. You have to ramp down your engines as you get higher. All rockets throttle. The shuttle engines too. The shuttle engine SRBs, regressive thrust curve. The SRBs. So okay, all right. You have combustion chamber geometry and rocketry, guys, okay? So that is so if you take, here, I'll show you. Paint time. So if you have a combustion chamber, right? Right? And your combustion chamber looks like this, right? And then you have it go down and you have it go into your throat. Like that. If you took this and you unwrapped it, right? You'd have something that looks like this, right? Right? The way you get the combustion chamber shape is you take something like that and you revolve it. You basically bend it into a circle, right? This is your throat. This total area right here is your combustion chamber surface area. I mean, obviously compounded with the injector plate or whatever's up at the top, right? If it's up at the top, then it looks like this, right? Looks like a half pipe. Okay? That right there is your combustion chamber surface area. Now, with a liquid fuel engine, your combustion chamber surface area is pretty static, unless you have some kind of ablative thrust chamber, combustion chamber, which I'm going to go ahead and assume that that's probably a thing somewhere, but I don't know the application, right? This total surface area changes with an SRB, right? So that's a liquid fuel rocket. When you have a solid rocket booster, right, a solid rocket booster is a lot bigger, so you have your entire combustion chamber, right? And then you have a bulkhead at the top. Oh, that doesn't look like it at all. And then you have something like that. Inside of the combustion chamber is grain. There's propellant in here. It looks like sand, almost, like that. They call it grain, okay? And then inside of that grain, right, there's a little tube, and that tube goes all the way to the top and all the way down. The SRB, when a spark plug basically ignites, or if you have an Estes rocket engine, you arc a piece of electricity in the combustion chamber with the igniter, right? Basically turn the engine on. And now this entire area fills with fiery bits. It fills with the fiery stuff, and then it shoots it out the bottom, right? Because it can't go out the top, right? So it shoots it out the bottom. It goes through the throat, a converging throat, and then out a divergent nozzle, right? Convergent, divergent. That's what all rocket engines, except for like an aerospike, is. An aerospike is divergent, convergent. It's different. It's the reverse of this, right? So as your grain burns off, right? As the grain burns off inside of the SRB, right? You're running out of fuel. The combustion chamber geometry gets bigger over time. And when your combustion chamber surface area gets bigger over time, you throttle up. The booster throttles up. Increasing combustion chamber surface area makes a bigger explosion out the bottom. You get more thrust. Cutting holes into the grain like this can change the amount of thrust an SRB has at, well, in this case, Cyborg, this one's at liftoff, right? Either grain or pace, depending on fuel type. Sure. Your face is an injector area. I mean, yeah, it's good for injecting food into my mouth. Last for the thrust curve, okay? So, Cyborg, you got your thrust curve here. Let me see. So, okay. Yeah, see that ramp down right there? That's what we're talking about. That's what that cut is. See how the thrust ramps down at the very end for like 10 or 100 milliseconds, basically? Can you start saving your paint doodle so I can make a scrapbook? Maybe. What design did the shuttle SRBs use? Guess. Oh, neat. Variable based on the mission? Nope. Regressive? Okay, it's a trick question, guys. The shuttle does have a regressive thrust curve in its SRBs. But you got to remember, you know how when the shuttle launches, they throttle back the shuttle engines? Well, guess what happens to the SRBs? They regress in thrust and then they increase with thrust. They pack the grain inside of the SRBs to throttle down for max Q, just like the shuttle engines. The SRB thrust curve goes like this. It dips. It was a star pattern. Well, that's just one of the segments. How they achieved the SRB to do that is each segment, the grain in each segment is packed in a little different way. So it's, as the grain burns down the SRB, right? If the first segment is just a hole, right, then the thrust will increase over time. If the second one is a star pattern, then it could increase even more. But it's not. They pack each segment in a different shape to essentially have the SRB's combustion chamber surface area be variable over time. And the SRBs they'll throttle up, and then they'll throttle down for max Q, and then they'll throttle up again, and then they'll regress off. They do a little dip. So they used each segment on the SRBs and they packed it in a slightly different shape to get the SRBs to throttle all the way up, throttle down for max Q, throttle up again, and then tail off. Yeah, they used each segment to basically make a throttleable SRB. That's a problem that I had to solve when we built the shuttle in KSP. I had to get, how am I going to make variable throttle? Because my SRBs have to work differently. They have to be independent of my shuttle engines, which I have to throttle down, right? And they have to shut off and regress in thrust over time. We don't have a solid rocket booster in Kerbal that can do that. That's strong enough to do that, I should say. So, I mean, you could use cal controllers with an SRB to program variable thrust. Oh yeah, you could use a cal controller and the thrust limiter to change the thrust limiter over time to make regressive or progressive thrust curves or static thrust curves. So linear thrust. So constant, right? But there's no SRBs in Kerbal that were big enough or strong enough to move my entire shuttle. So I had to use liquid fuel engines that shut off automatically over time as the shuttle goes up to create the regressive thrust curve. Chapter 12 of RPE is very helpful to understand this. Can you read this on stream? Okay. Did the shuttle have to adhere to a strict payload regime? Like, could it ever launch with not a lot of payload? The shuttle can carry whatever it needs to J-speed from 0 kilograms. It could launch with an empty payload bay if it needs to go get something. 0 kilograms all the way up to 25 tons and anything in between. That's something that I learned from building Collins in KSP. That's where the shuttle engine gimbals come in. The gimbals come in to compensate for the... Give me a second. The gimbals on the shuttle are there to compensate for the linear center of mass travel due to differential payload mass. What does that mean in plain English? If the shuttle's flying into space and nothing is in its payload bay, the shuttle engines don't really need to gimbal a lot. They just need to gimbal to keep the shuttle and the ET flying on an even keel. Okay? If the shuttle's carrying 25 tons of Hubble Space Telescope in the payload bay, the center of mass drain is still linear. The center of mass, as the external tank drains, will still trend towards the space shuttle. But that linear center of mass drain will be different depending on what payload you have. And that's where the shuttle engine gimbals come in. So I'll draw up another little chart for you guys here, all right? Let me get I'm just going to use a picture of the shuttle and the external tank here for this one. Here we go. Here's a good one. Let me just get a picture up for you. What's that picture called? Okay, here. So check this out. This is a picture that I took from the shuttle's aft cargo carrier. Just ignore this. Just pretend the ACC isn't there, okay? So, the external tank has locks up here, and then it has LH2 right here. LH2 has to be stored at a very low density. Locks can be stored at a very high density because hydrogen is a pain in the butt. All right, long story short. If you try to pressurize hydrogen, it will basically be like squeezing a sponge that's full of water. Yeah, if you try to make it high pressure. So the hydrogen tank needs to be a lot bigger than the LOX tank, right? So if the shuttle is carrying no payload into space, the center of mass between the mass of the LOX tank and the mass of the LH2 tank is literally right here. The center of mass on the external tank by itself stays right there. It's right on that brace. Right? The center of mass for the ET. I should label this correctly in case somebody sees the end of this. All right, and now where's the shuttle center of mass? Shuttle center of mass is right here for the most part. It could be different depending on payload, but it's the shuttle's dry COM, or not dry COM, the shuttle center of mass is right there. We know that from basically where the landing gear is. The landing gear is right here on the shuttle, right? So you know that its center of mass is right there. Check this out. See what I'm talking about? It lines up perfectly with the angle that the engines are placed at. Now, say the shuttle, this is what it would look like if it's doing, like, say, a Hubble servicing mission. There's nothing inside of the payload bay except the mount for Hubble. So your center of mass on the shuttle stays right there, right? However, say you're carrying a truss segment for the ISS that takes up the entire payload bay. Now where's your center of mass? Well, the center of mass is going to be a little bit more forward. It's going to be a little bit more forward and a little bit up. This is where the gimbal vector range of the RS-25 comes into play. .5 degrees. Because if the shuttle is carrying nothing in its payload bay, that line goes basically right here. Right? Now if it's carrying something in the payload bay, the dry center of mass shift works like this. It moves up. Right? So if it's right here, these engines don't need to gimbal at all. Right? But if it's up here, now the engines have to point at that center of mass in order to get the shuttle to fly straight. If you're carrying a heavier payload, this line shifts. Linear center of mass travel between initial and final mass has a differential shift if your dry mass with the shuttle is higher, meaning you're carrying more payload. Gimbals help with junk in the truck. That's why they're there, dad joke. Now the engines, you know, if your center of mass is up here as you're draining fuel and your center of mass travels this way, the engines can turn and they can compensate for this line being shifted up. This is why, and this is why I pulled up the aft cargo carrier picture. This is why the shuttle, they proposed that the shuttle could have a cargo bay down here, because it's the same thing, only shifting in the other direction. This is why the engines can gimbal on the shuttle, to take into account differential payload mass. But that center of mass drain, the distance, basically the distance where the dry center of mass is and the wet center of mass is, so as you drain fuel, the center of mass doesn't move up. It doesn't curve, it stays the same, but it shifts up and down. Yeah. How did they solve the differential center of mass on Buran? They offset the engines on Energia. How did they make it burn in one direction and keep the full thing going up at once, like BP? What do you mean BP? I'm confused. Why didn't they put an engine at the back of the center tank? Because you don't need to. You don't have to. Putting an engine down here is a waste of time. If you have a gimbalable engine, you can compensate. How did they make it burn in one direction and keep the full thing going once? I mean, the shuttle's main engines are its upper stage engines. That's the main engine. The external tank doesn't come back. You get rid of it. It's not a thing. It's disposable. The point is you got your propulsion systems back. Guys, all the shuttle stacked on the side of the external tank is a rocket. So picture a rocket engine down here, right? You have your rocket engine, right? All that is this shifted up here and rotated 15 degrees. It's literally just a rocket that's up here. And it flies as such. I mean, yeah, RS-25s are overbuilt, but yeah, they use the differential pressure in propellants, in Hydrolox propellants, to compensate for the fact that they had a 60-ton orbiter hanging off the side. I don't know, Seacracken. You'd have to check with somebody that knows a little bit more about it than I do. How do the SRB fuel not go up like black powder? There, ask that the better way. What do you mean up like black powder? What do you mean? The SRBs are segmented, right? And there's a cap at the top. There's a bulkhead at the top, and then there's an open nozzle at the bottom. If you try to pressurize that, it's going to go out the nozzle. What do you mean up? I'm confused, Goldie. What does that mean? I think he's asking how it's a controlled burn, not a boom. Well, that's how you engineer the propellants, man. Oh, you're talking about the okay. That's how they physically make the grain. Some grain, like, okay, all right. Remember the atmospheric penetration video, the parameter video? Did you see that when I showed it the other day? So if you have kindling versus a bunch of logs and you're trying to make a campfire, you throw a match on the kindling. It'll burn up instantly. But if you throw a match on a couple of logs, you got to stoke that fire. Anybody, Boy Scouts, Girl Scouts, anyone? You got to stoke it. If you don't stoke it, it'll just go out. But if you have kindling, like if you put dry leaves down and then you try to light it, all right? The density of your fuel really makes a difference. SRB fuel is like that. It burns slow on purpose. Black powder I think it's density. Rocket guy, is it density? It's density, right? It's the density of your grain and what your grain is made out of. Different. I mean, I'm pretty sure that's correct, but it's been a while since I've read RPE. I'd have to go read it again. There's a whole chapter on it. Surface area. Yeah. I mean, Rem, yeah, it comes back to that. Yeah. Hand banana. Okay, there you go. Surface area as well. Yeah. I mean, goalie, if you have black powder, it's powder, so there's a lot of little grains, right? And then the entire grain surface area is exposed to the fire, so if you throw it on there, just... If you take that packet on the walls of an SRB, right, and then light the SRB, it'll only burn the grain that's touching the fire, and it'll slowly burn out. I mean, but then again, there's a reason why they don't use black powder in solid rocket boosters. I mean, black powder is terrible impulse if you really want to know. I mean, rocket guy, you tell him. Black powder and smokeless white powder is terrible. Bullet casings have terrible specific impulse. They're actually super inefficient. Why? Because you need an energetic reaction to get a bullet to do bullet things, right? Can you build an SRB fuel with black powder? I would not go around messing with this stuff, Enerline, unless you made sure your local government or whatever was cool with it. Don't go screwing around with this stuff if you don't know what you're doing. There are channels that you can go to get proper certifications, and there are bodies, governing bodies that will help you do this. You need to get what's called an L1 certification if you want to launch an SRB a long way up and far. Do not go screwing around with rocket engines, especially if you don't understand them. Very bad idea. I have to say it, and just to be sure. Aurelian, I have to say it. Trust me, don't go screwing around with this. Yeah, you're gonna blow your hand off or get arrested. Don't do that. Going through the proper certifications is not hard, guys. There's plenty of people that do it. There's plenty of people that watch the stream that go and do it. Damn, nanny state got to get in the way of everything. John, you know it's probably better this way, especially with screwing around with rockets and guidance systems. It's probably for the better. Artyom, as a firearms designer and a gunsmith, I would like to add to the conversation, but I know nothing about gunpowder. I just build the gun. Well, I mean, the thing is, how an SRB works and how a shell casing works, literally the same thing. It's literally the same thing. Only instead of loading a shell casing and, a bullet attached to the shell casing in a breech, right? And then, boop, you hit the primer cap on the back. An SRB is just the shell casing with the primer cap. SRBs have primers. They're big. Cool. Really cool stuff. They have primers. It's the same thing. All right? Take a shell casing with white powder in it, right? And then all an SRB does is, instead of, if you took an intermediate cartridge, take 7.62 by 39, right? Take that. And at the bottom, you just make a funnel instead of it being canted in to shoot out a lead cartridge or a lead bullet, right? You make it enough so it impinges on the gas, just like the impingement system on an AK. It's the same thing. You're squeezing the gas through a nozzle. That's literally what an SRB is. Don't go screwing around with shell casings and trying to make rockets with them. You will blow your hand off. Don't do that. Not you, Yuri. Anybody else. It's the same thing. You're still getting that energy release, only the energy release is used to propel a bullet down the barrel, right? And then spin it because of the rifling, but that's another story. But hey, rockets have spin stabilization too. Funny how that works. I mean, an SRB is basically a shell casing. It's just a shell casing, but the shell casing is what goes instead of the shell casing shooting a bullet out. That's the difference between a gun and a rocket. They literally do the same thing. They combust something to release a crazy amount of energy all at the same time and get it to do some kind of kinetic energy, Okay, later, so EJ told me to build. Yeah, dad joke. Yeah. It's cool stuff. I mean, how firearms work is super interesting. I think that, like, if I'm gonna go there, like the short stroke system that Gene Stoner came up with for AR-based design guns is really, really smart. Using a short stroke gas impingement system really, really mitigates recoil. Kalashnikov with his gun, and keep in mind it's older, right? They have a long stroke system, so AKs are very susceptible to recoil because that bolt is going. The difference between the forward and the forward and back trunnion is a long way. It's a really long stroke piston. Still sad about the G11 being scrapped. The box with a trigger with a pistol grip on it, yeah. Yeah, I mean that's what makes the recoil in an automatic firearm, guys. It's the stroke. I mean, the bullet going out does kick a little bit, but the recoil that makes the thing go up is the fact that you have a gas impinged bolt that's using some of the bullet's energy that gets released to go through what's called a gas block, down a gas tube, and it hits a piston back. Just like a piston in a car, same thing. It hits a piston back, and that piston is attached to a bolt, to the bolt carrier. Well, it depends on the gun. And then it goes back, it pushes the hammer back, and then when it goes forward again, it loads a new bullet in. It's pretty straightforward. I mean, it's very simple stuff. I mean, kind of primitive mechanics, if you ask me. But then again, a screwdriver is simple too, right? Does that mean it's bad? No. You never struck me as a gun guy. I like the engineering behind them short lines. Very interesting concept. I mean, I like the engineering behind it. Gee, did you expect anything less? Like, well, the stroke of the piston definitely matters, Savvy. I mean, yeah, obviously the bullet leaving is going to kick a little bit, but I'm not talking kick. I'm talking recoil up. I don't know enough about guns to know what the difference in terminology that is. The number of times I've fixed failure to eject cartridges by just pulling the buffer tube assembly spring just a little bit. Huh. Does that mean that guns would have kickback if there was a second grip on the top? If you had your pistol grip above the barrel and you shot, the gun would do this. The gun would go down. Yeah. Yeah, that... American, of course you like guns. Hey, Canadians like guns too, I think. It's just interesting. I like the engineering behind them. It's really cool. Like an open bolt system, man. The fact that thing can move that fast and just go down range is pretty crazy. Heck, even a frigging minigun. How a minigun works is ridiculous. So a minigun has an auger in the feed mechanism. So a belt of ammunition comes in, right? And that auger picks up a bullet, and the auger is crooked. So when it spins, it kind of wiggles. Like, think about like the earth wobbling on its axis because we have an axial tilt. Same thing, right? When it spins, that auger moves forward and back. And that forward and back rotation of the auger loads a bullet, fires it, and then ejects it out the side. And it just keeps using... It works like a roundabout. Literally a roundabout, like with cars. It's the same thing. Really, really interesting stuff. Like, Gatling, the funny part of that story is that Gatling was a pacifist. He invented the minigun because he thought if people saw this weapon of mass destruction, they would just not even bother because it can just cut down people, right? He was a pacifist. He thought that he was on the right track with mutually assured destruction. But yeah, it took a little while to get to that point. I'm not sure, Barak, maybe. Then there's the A10. The A10 is a 30mm depleted uranium minigun. It's about this. The minigun assembly and the loading mechanism is and the barrel is bigger than a Volkswagen Beetle. I mean, you can go on the A10's wiki page and you can see that picture. It worked out real good. I mean, Bauxy, guy was on the right track, just about 150 years too early. Well, let's say 100 years too early. Gatling was Civil War. He built the Gatling gun during the Civil War, and he thought that if anybody saw this thing on the battlefield, they wouldn't want to fight. I'm telling you, Gatling was a pacifist. And then in the 50s, they came up with the idea of attaching an electric motor. The original Gatling guns were hand cranked. You just and then somebody along down the road came up with the idea of putting a brushless motor on the auger and just and that's how you got the from happening. Yeah, they did that in the 50s, and then the first Gatling guns saw use on, what was it? I think it was AC-47s, if I'm remembering right. Because you mentioned it, the A-10, what exactly does depleted uranium mean? Not radioactive uranium bullets. Okay, Hip, remember when were you here when we were talking about nuclear stuff yesterday? Or not yesterday, the other day, when I was talking about what nuclear stuff does and how nuclear fuel works? The depleted uranium round. So what happens to a bullet when it comes out of the barrel? Well, first of all, it's spinning. Second of all, it's really freaking hot. Because it had the friction from the barrel and it has the heat from the explosion behind it, right? Thanks, Jawa. Sorry, I missed that. Is the brushless motor how we got the what? The Gatling gun used to be hand cranked, dad joke, and it kind of died out because it was too big and too hefty. And then in the 50s, somebody came up with the idea of putting an electric motor on the back of a hand cranked minigun, and that's how got invented. Like the modern minigun. That's how that got invented. They used a design from the Civil War and they put a motor on the back. I just wanted you to make the sound again. Yeah, he likes to talk. Depleted uranium is what's left over after you enrich uranium. Yep. Savvy C last. It's all about the force transfer. If you brace against your shoulder in a direct line behind the barrel, then the recoil will be linear, no muzzle rise. Same goes for the bolt. That's why an AR doesn't climb as much. The entire gun is linear, barrel action and buttstock. Yeah, actually, that's a good point. And it's short stroke, but the short stroke isn't. Yeah, I didn't think about it like that. Good call. So depleted uranium is super dense, first of all. And second of all, when it hits something, it gets even hotter. And it basically is used to pierce through things. Now, fellas, I'll be 100% sure, or 100% honest. I'm not 100% sure. Like, I know it's dense, and I know that's a good... You want something going at high velocity that's very dense, that has a lot of kinetic energy. You get more stopping power that way in terms of firearms, right? But when a depleted uranium round hits, is there any neutron flux that's going on when it impacts something? And is that used to its advantage? I'm quite dense too. Takes one to know one, I guess. What is a brushless motor? A brushless motor is just an alternating current electric motor. Also, the barrel of a rifle is really close to the same as a rocket motor. Gas. Yeah, that's what I'm saying, Savvy. It's basically the same thing. It's just, and that's what it goes back to what I'm saying. That's what I tell people. Engineering's all about application. What are you trying to do? That's all. Depleted uranium is basically recycled nuclear fuel pellets that ran out of U-235. But Victory, what I'm wondering is if they use that radioactive material to basically. So. Is it just because of the density of the uranium to pen? It's better at penning armor if it's dense. That's why Sabo rounds use tungsten. So if a tank is shooting an armor-piercing round, it's a tungsten rod. And that's part of the reason why, like an Abrams cannon on the M1 Abrams uses a smoothbore cannon. There's no rifling on an Abrams. I've looked in the barrel. There's no rifling in there. There used to be, but they switched it to a 120 millimeter smoothbore cannon so they could launch Sabo rounds. Depleted uranium is very hard, and it burns if it pulverizes on impact. That's what I'm wondering, Freshmans. Is it a little mini nuke? Little mini nuclear explosion, little tiny amount of neutron flux going on in there when it hits. I mean, I would assume probably yes, but I'm wondering if that was the purpose of the round or if that's just a byproduct. It's used as it doesn't mushroom like lead does and stays sharp on impact. No. Okay, so it's just because of the density of the material. Got it. Yeah, okay, cool. See, that part I didn't know. That's why they use it. Yeah, my question was about why using uranium was advantageous. Yeah, Hip, I wasn't very sure. I knew it was density, but I'm wondering if there was some flux going on there. If, like, every time you hit it, it's a little nuclear reaction. But no, it's more about the density of the uranium. Cool. Today I learned. All right, anyway. Want to keep going with space news? Yeah, okay, I got you, Victory. Yep. All right, let's go. So, this is coming from Flight Club here. Well, tungsten flattens out while uranium is sharp. That seems to be what's going on. Yeah, okay, cool. Good to know. Okay, trying to model stage separation via centrifugal force. This is coming from Flight Club. I have no idea how they're going to pull this off. Separation velocity is so freaking low with these huge masses. The only technically need to get 20 centimeters for the rotation, for the clearance rotation to work, but damn. Oh, Flight Club is doing some Starship simulations. Why not pitch up rather than pitch down? I'm not sure. When it penetrates around the edges of... Oh, see, that's super interesting. That's super interesting. Dude, who the hell thought of that? Like, who the hell thought of that? You know how much finite element analysis needed to be put into, like, figuring out that depleted uranium actually sharpens itself on impact? Like, who the hell thought that up? What? Like, what? Why? Like, why would... What? Hey, Matt, 21 3 subs. Dude, that's fascinating. I don't like that, you know, like, they use that to kill people. Like, that's not cool, but the engineering is, like, who thinks of that? Come on. Mina. Yeah, that's right. That's right, Boxy. It's down to show the ship is tossed forward instead of backwards. Yep. Depleted uranium is denser than lead. Better than that. Yeah, I mean, John, don't get me wrong. How many hours do you have in KSP? Adsy's over 10,000. Easy. Red Munchkin, thank you for the raid. Lock up your snacks. It's a Munchkin raid. Thanks, man. Interesting. Yeah, the separation system is something that I've, you know, it's interesting how they're going to do that, but pitching down means it uses the momentum already in the vehicle since it's leaning over for orbit anyway. Yeah. I know this one. During the Manhattan Project, they did do some test firing uranium into objects to measure a change in criticality. There's a strong chance they noticed it there. Sounds right to me, Bio. I hate how everything is... Every piece of good engineering out there can be... Well, not good engineering. Every freaking piece of engineering always traces back to us looking for a better way to kill ourselves. It's like, oh. We... Really? Like, come on. Everything. Even rockets. Like, it's like, well, alright. Thanks for the shout out. Hey, no problem, Red. Yeah. War's a good motivator. Yeah. It's that whole survival thing. And John, for what it's worth, don't get me wrong, I'm not really that big of a fan of weapons, but I understand exactly why they exist and the reason. So I'm not ignorant to that either. I just don't really like the idea of, you know, killing someone. That's not, yeah, not really a fan of that, but I understand why. I understand why we do. Like, I'm not gonna sit here and bury my head in the sand and say that Earth is a perfect place, because that's dumb. You know? It is what it is, man. War is progress in a bottle. Sometimes you need to let it out. That's a good way to say that. Alright, let's go. So, this is coming from Perseverance here. Update on my first sampling attempt. Looks like the rock I drilled was too crumbly, and it broke into small fragments and powder instead of producing an intact core. Pushing ahead to find the next target. Expected it to be more like rocks that we cored on Earth. So let's take a look. Perseverance did do a sample collection, or they tried to take a core sample for that. Oh, sand. Huh. Interesting. Interesting. So, something I didn't notice before. So this looks like sand, right? That looks like sand that you'd find on a beach, which is interesting because they're in the Jezero crater. Jezero crater is basically, it was an estuary, right? At least they think it was a river estuary. If you looked at the Jezero crater from space, it looks like a river delta. See, what's interesting here, guys, is if you look at the sand that was drilled out from the core versus the sand that's on the top of the Martian regolith there, look at the color. Look at the discoloration. That's super interesting. The reason why Mars has its red color is because rust. The surface of the planet, the metals that are in the regolith rust. That's why it's red. But the sand that's just under, or the soil that's just underneath it, not rusty. Interesting. I never noticed that. I didn't notice that until just now. Yeah, no oxidization, because there's no air down there. Interesting. That looks like beach sand, man. Huh. See, and if it's not rusted, dude, this is why we just need to send somebody with a damn shovel. Like, I know that's easier said than done, right? Send somebody with a damn shovel. A guy could dig a hole like a couple meters deep. Can you imagine if we dug like a couple meters deep and we found water? That's entirely possible. And they've documented water flowing underneath the soil on Mars. That's a thing. Can we also talk about the picture quality? Yeah, right? Send a drilling rig. Bruce Willis. Wait. Steve Buscemi. Mars is wearing red makeup on a great face. That's broken. I like that way. That's a good way to put it. But you know what's crazy? When Insight dug the terrain out, I'm wondering if Insight dug that terrain out, if it was the same thing. It doesn't look like it. But then again, this could be color corrected. But it doesn't look like the soil. Yeah, I don't like sand. It's coarse, rough, and it gets everywhere. Maybe it depends on the location. Well, Addie's, the way I look at it is that it definitely would depend on location on Earth. Obviously, if you went to Nevada and you dug a 1-foot hole, what you would find is completely different than if you went to Florida and you dug a 1-foot hole, right? Or 1/3 of a meter into the ground. Or 330 millimeters. Like, it would be very different. So, does Mars have localized climates? I mean, I'm pretty sure they already knew that, but still, cool stuff to think about, I suppose. But it's interesting that in the Jezero crater, that it's sand. It looks like beach sand. Huh. That looks like sediment that was deposited by a body of water. That's cool. Yeah, Saul, Apollo 17. Yeah, the orange soil. You guys know about that? Here, check this out. Yeah, they went and dug a 1-foot hole, and that's what they found. This is not a doctored picture. They found orange soil. Orange dirt. If there only was a way to catalyze the carbon dioxide into carbon monoxide and oxygen, that'd be pretty nice, Lion. Here, how about we send a starship out there and figure that one out? Yeah. Pretty crazy. Shameless plug for some of the pictures that Jack Schmitt and Gene Cernan took for Apollo 17. Apollo 17 spent 3 days on the moon. And it was the only mission to have a scientist on board. Jack Schmitt is a geologist. Harrison Schmitt, he's a geologist. The guy's still alive. He works with Blue Origin, believe it or not. He works with them on the national team lander. Well, asterisk next to that statement. Yeah. Look at some of the EVA pictures from 17. They will blow your freaking mind. Look at, dude. Look at that damn picture. That's nuts. I'd love to see what that spot looks like today, right? I think personally one of the Artemis missions should go to an Apollo landing site. I'm serious. I know we're targeting the South Pole of the moon and stuff, but I want one of them to go to the Apollo landing site. It would be good. It'd be a good scientific study to evaluate how that thing held up over 50 years. We really did that, huh? Yeah. Pretty crazy, man, when you think about it. Yep, 48 should be enough. There's three lunar rovers. There's 3 LRVs on the moon from 15, 16, and 17. Yeah, size up, I know. Its battery would have been totally... Yeah, Mintalk, yeah, the battery would have been... It's probably not good. I mean, you don't want to leave a battery... You don't want to leave a battery out for that long here, let alone on the moon. The moon's a little bit more of a adverse environment, we'll say. I mean, guys, like, another thing that shameless plug for Apollo 17. Apollo 17, Jack Schmitt and Gene Cernan drove that rover, like, 5 miles away from the LEM, from the landing site. Can you imagine that? Like, think about that for a second. You know, Neil and Buzz, when they landed, they spent like less than a day, like 18 hours on the surface, and then they left. They walked around a little bit. They planted a couple experiments. Can you imagine driving that far away from the LEM? Would you do that? Would you drive 5 miles away from the LEM? They did. Yo, that's crazy. I mean, I would too. Like, don't get me wrong, but the further you got away, I would be very, very cautious. I'd be like, nope. What's the plan? We're doing the plan to a T because I am scared that I will pop a tire. Well, not pop a tire, but like, or if something breaks, you got to walk back. Oh, that would suck. It's crazy, man. In Andy Weir's second book he wrote after The Martian called Artemis, they built viewing buildings for lunar tourists around the original landing site and the descent stages. Yeah. Cool. Yeah, Bio, that's a great picture. Not space news, but still cool. Oh, neat. Walk back, you just hop back. Well, yeah, obviously, right? Can you imagine? That's ballsy, man. It's very ballsy. All right. So, cool stuff about what's going on other planets. Let's see. We got 10 minutes, and then I'm going back to KSP. Never worry. I press F5 every 2 minutes. Which mission serviced the lander that they landed near? That was Apollo 12, Swishio. Yeah. It was Al Bean and Pete Conrad, I think. I should have that memorized. Yeah, they landed next to Surveyor 3. The whole point of Apollo 12 was to prove that they could do a pinpoint landing on the moon. They could land next to something. That was what Apollo 12 was testing. 13 was testing how badly you can screw up. And it kind of was an unintentional test, but Yep. You'd end up with extra footprints on the moon and a good story. Yeah. I mean, but personally, I think one of the Artemis missions should land at Apollo 17's landing site. I've listened to a lot of Gene Cernan talk about going back to the moon, and Jack Schmitt is still with us, which is awesome. I'm sure that's what Gene would have wanted, but I mean, I suppose if somebody asks Jack, that's probably what he would say. Pick up right where we left off. Why don't we go to the moon again? Do we know everything about our satellite? We know nothing about it, Addies. We've literally just scratched the surface. That's about as far as we've ever dug onto the surface of the moon, right there. Also, like I said, some of the pictures from Apollo 17 are insane. Yep. Why haven't we been back to the moon? Purpose, mostly. To be fair, we know more about the moon and Mars each than we do about our own ocean floor. To be fair to who? Is it a contest, John? Like, I mean, personally, we should find a way to send somebody down to the Marianas Trench and figure out what the hell's going on down there. That would probably be useful too, but we can do both of those things at the same time. To be fair to the fish, man, screw the fish. I still can't find them. All right. Anyway, let's keep going with the space news. To be fair to James Cameron. All right, that's fair. Supply of small launch vehicles continues to grow. The number of small vehicle projects... This is from Jeff Faust over at Space News. The number of small launch vehicle projects continues to grow despite the pandemic and the widespread belief that there is significant oversupply of launch vehicles. But growth may be showing signs of slowing. In a presentation at the 35th Annual Small Satellite Conference, Carlos Niederstrasser of Northrop Grumman provided an update to an annual survey of the small launch industry that he has produced since 2015, tracking the growth of small launch vehicle development efforts worldwide. The survey includes those vehicles with payload capacities no greater than 1,000 kilograms and available to commercial or U.S. customers. The total had grown to 155 vehicles, he said, ranging from 10 vehicles in operation to several dozen that have gone defunct since the survey started in 2015, when about 30 vehicles were included. I was really expecting to see a slowdown in the number of new launch vehicles that we're seeing coming out of the woodwork in the last few years. It turns out that the slowdown does not happen at all. Interesting. There have been some changes in the industry, though. He found that a number of vehicles in active development declined slightly from last year to 48, with a decrease as well in the number of vehicle concepts on a watch list that have not entered active development. More than 40 vehicles are now classified as defunct, about 10 more than last year. This is not surprising given the challenges of getting one of these vehicles fielded. For those launch vehicles that have folded, one factor has been dominant, funding. If you got money, you stay alive. If you run out of money, you have to close up shop. Striking revelation there. It's a joke. No other trends in terms of vehicles or countries where they're being developed stood out. Among vehicles in operation or under development, the United States has the most, accounting for 22 of 58 such vehicles. However, 6 of the 10 operational small sat launch vehicles are Chinese, thanks to the growth of the small industry ventures there like Galactic Energy and iSpace. iSpace. That's the best name you could come up with? Come on. Really? iSpace? iSpace. Okay. India is emerging as a new hotbed of launch activity with 4 small launch vehicles under development by companies after government reforms backed commercial launch ventures there. In a pre-recorded video presentation, Niederstrasser said that he was seeing some level of realism enter the market with the slowing growth in number of vehicles, but couldn't rule out some effects from the pandemic. I think we'll have to wait another year or two to determine that. He said in the conference session that he did not expect many launch companies to merge given the difficulties of finding 2 companies with complementary technologies and sufficient funding to develop them. I think finding both of those items is going to be hard for most of these competitors. He also added that any slowdown in the small launch vehicle development should not be confused with market saturation. I think we've reached market saturation back in 2015 when there were 30 or so folks trying to build vehicles. The current vehicles in operation may be more than enough to serve demand, but exactly how many vehicles are needed may not be clear for some time. It will be some years before we realize when we've reached that point. Interesting. Yeah, that feeds into a much bigger question, and no one can predict this question, so it goes to a matter of opinion. You know, do you build a launch vehicle to service a market, or do you build a launch vehicle in anticipation of a market? So, like, say you're playing like Factorio, okay? And you need resources to go from the mines to the factory, right? You'd build a conveyor belt out of need, right? Now, say you want the products that factory produces to feed into another thing. Do you build a train line out into the middle of nowhere to build a new factory and then assume that the demand is going to come with it? You might find a better way to do it, right? It's like a chicken and the egg thing. I personally, this is me, and this is everybody can weigh in on this, I suppose, if you want to. I think if we build more rockets, more demand will come, because the more rockets in the market makes the price go down due to competition, and if the price goes down, it can lower that tide enough to where, instead of just billionaires launching things into space, it could be millionaires launching things into space. And chat, there's a whole lot more millionaires than billionaires out there. Anticipation of a market to bring a bigger market. Yeah. So, King, the other thing that I think about is that rockets are a transportation system. That's it. It's a form of logistics, like a truck. I mean, the space shuttle was referred to as a space truck all the time. It's a truck or a train or a cruise or a container ship or an airplane. It's just a form of transportation. Now, what I do is I look at what industries were chicken and the egg or egg before the chicken. So I use the car as a good example. The car, there was no industry for a car before Henry Ford came along and started making a ton of them to bring the price down enough to where everybody could afford a car. Can we do that with rockets? No, not really. Kind of, maybe? I don't think that... we're going to need to make a lot of rockets to get that done. Another example would be with the electric car and Elon Musk, who basically took a page from Henry Ford's playbook and just did it with electric cars instead of gasoline cars, right? Ramped up production, flooded the market. Now there's demand. Now everyone wants a Tesla, right? Not everybody, but you know what I mean. The demand is quite high. Do you think China have a shot at beating SpaceX to Mars? Maybe, Zenith. I wouldn't... SpaceX is further than China in terms of reuse and in terms of being of throw. Falcon Heavy can move way more than Long March 5 into space. But I don't think it's wise to underestimate the Chinese resolve. I would not do that. If the Chinese decide that they want to aggressively pursue the moon, they'll do it, and they will succeed. There's no way that that's not going to happen if they decide to do it. The question is, what's going to prompt them to? Resolve equals hackers. I mean, what? Hey, the means to get there is having... Latin America is creating a space agency of sorts with the aim in all sats, so all this news seems good in this aspect. I personally think if we flood the market with launch vehicles, Saul, that the price will come down. Elon thinks the same thing. I'll say I agree with him. I'm kind of parroting his opinion on this one, but I think that's right. I think that's the correct way. Because rockets have this problem, dudes. They have this problem that it's sinusoidal. Demand over time. So if you have this, right, and you have time, and then you have demand, right? Because satellites have a service... That looks like diamond, but spelt badly, but you get the idea. The rocket market, because satellites have a service life of about 10 years, does this. It's sinusoidal. It goes up and down. There needs to be a way to make it do this. But it doesn't. It just keeps doing that. You need to make it grow if you want the market to get better. And so, people think that flooding the market with rockets and more rockets is the way to do that. This is why I always say, like, I want NASA to launch more rockets. I want SpaceX to launch more rockets. I want China to launch more rockets. I want Russia, the Europeans, all the commercial providers. I want everyone to launch more rockets, because if we do that, then the demand trends upward, right? But just because you flooded the market with launch vehicles doesn't necessarily mean that the demand is going to go through the roof. Sometimes you have to do things. Now, SpaceX, the way they're flattening sinusoidal demand is through Starlink, right? And that, I mean, Falcon 9 launched a ton this time. It's launched a ton already this year, like over 20 launches, and most of them were Starlink. 1 or 2 of them were for somebody else, right? There's the transporter missions, and then there's Crew 2 and 2 cargo Dragons, and then another crew mission at the end of the year. That's that sinusoidal demand that I'm talking about. But SpaceX, Elon was able, because he thinks that, was able to bridge the gap with Starlink. And the maintenance for Starlink to keep that internet satellite constellation operational, the profits from Starlink will more than justify, having a rocket that can constantly resupply and rebuild Starlink, because the satellite life on Starlink is only 5 years. Those sats up there don't really have a lot of fuel, and they have to use a lot of fuel because they're skirting the atmosphere. So that makes a satellite constellation that constantly needs maintenance. That is inflating the demand for SpaceX, at least internally. But we know that there's other people that want to compete with them, like OneWeb and Project Kuiper over at Blue Origin, which is Amazon's internet satellite constellation. You see, SpaceX having, goosing their internal demand by doing Starlink is creating more demand in the market. That's what I mean. You flood the market with rockets, and then you give them a mission, right? That can create a market. Somebody's going to say, oh, I want my own. Jeff Bezos will say, oh, I want my own internet constellation, and I'll launch it myself with my own rockets. Boom, more demand right there. Which, like I said, it's an interesting thing to think about. Russia can launch a lot of rockets, but there's nothing to launch until OneWeb came along, Kem. How many Roscosmos launches or RSC Energia launches have been OneWeb this year as opposed to Soyuz? See what I'm talking about? All it's going to take is enough people coming along and making their own demand like that. Like, look at Rocket Lab. Rocket Lab has the photon thing. They can basically, all you got to do is give them the sensor and they'll make it for you. People are trying to entice people to build up the demand. Even relativity with 3D printing rockets. Firefly with mass producing subcontracted components to rockets. They're trying to create the demand to try and get that sinusoidal demand to flatten out and go up. It's a really hard problem to solve. And like I said, you can look at cars, you could look at trains. Trains came out of necessity. Trains was a better way to do things. Cars necessarily wasn't a better way to do things, but it was easier. And if you flooded the market, you end up making a lot of money. It's a tough problem to solve, and that's something that we're certainly going to face. We're going to see some of these small sat companies fold over the next couple of years. It's going to happen no matter what, even if they do flatten out the demand. One, having this many LEO satellite constellations screw with our launch capability. What are the consequences of this? I don't know, Dara. Seems like a recipe for Kessler syndrome. It is. I mean, at least with Starlink, Starlink satellites. If SpaceX just shut off Starlink right now and said, "Screw it, we're not doing this anymore," the entire constellation would come back down in 5 years. Yeah, there would be no Starlink in 5 years if SpaceX pulled the plug. All their satellites are in decaying orbits, and the decaying orbit coupled with the satellite shelf life creates demand for rockets. You need to maintain the network. It takes that sinusoidal demand once again, and it constantly needs to be resupplied, and just makes the demand go like that. That's why they're going to use Starship to service the Starlink networks. At least that's what I think. At least I think that's what they're going to do. The whole space mentality needs to change. Most of the companies only make rockets for certain mission parameters. They don't really compete all that much. 2 companies have rockets that can overlap with certain missions, but one is always more efficient to do one over the other. That's why we only have Mack trucks driving trucks around, right, King? There's no Peterbilt, there's no Kenworth, there's no Sterling. That's not how that works. There's way more than just 2. And they do all have a lot of overlapping missions. Very shortly after cars came about, we started racing them. See any rocket races in the future? That would be cool, GUI. I don't know. I think with that, it's going to be more about setting records. It's going to be more like the airplane in that regard. I mean, there is the Reno air races, and that's really cool. But, you know, when in the golden age of, like, flight, like in the 20s and the 30s, right up until the war, it was more about setting records with planes. I think that's what we might see with rockets. Hey, Slumby. I agree, Rocket Guy. We need to change the way we think about it, and that's why I have these conversations here, dudes. You got to change the way you think about this stuff. You can't keep, like, even Starship. Starship is a paradigm shift in thinking about how you build a rocket. It's fully reusable. Even 10 years ago, having a partially reusable rocket, everybody said wasn't a good idea because of the space shuttle. You know, everybody, the money was in building expendable launch vehicles, like what ULA does. That's where and one could argue that money is going to always be there. I agree with them on that. I've been busy the past couple of days. What's the deal with NASA's suits? Well, it's past 6 o'clock, guys. I'm going to bust out the rest of this news real quick, and then when I get back into Kerbal, we can keep talking about this. So, let's see what we got here. Cosmodrome Vostochny. Okay, yeah, all right. At the Vostochny Cosmodrome, crews have started work on the Fregat upper stage as part of the 49th mission for OneWeb. There you go. Specialists removed it from storage and installed it in the workplace. Electrical, hydraulic, and pneumatic vacuum tests should begin soon. Rocket's already doing that. 100 launches without failure. Yes, I'll get into that in a moment. All right, so that's cool. Another OneWeb launch out of Vostochny. But Kem, you even see it across the board. This demand, OneWeb wanting to compete with SpaceX has created demand for Soyuz that otherwise would not be there. So once again, it's chicken or the egg or the chicken. I really think that if we flood the market with launch vehicles, so my mentality is always more rockets. More rockets are the way to do this, not less. And that's why I always advocate for everybody to launch more rockets, as long as it's peaceful. I'm cool with that, and I'm cheering everybody on in that regard, because that's if we get that growth and we get that demand to reach a certain point. That'll seal the deal, and then before we know what's going on, going to low Earth orbit will be like taking a plane across to Europe. But this is how we do this. Everybody needs to launch more things. 1 minute Russian video, okay. Ah, yes, update on Angara's pad. I don't know if it'll be at that level, Swishio, but maybe like a plane ticket. What does that say? Construction on August 5th, 2021. 2042. Wait, what? What role do you think the governments of the world will have in space enterprises with the rise of multinational corporations' advancements into space? Taco, I can sum that up in one sentence. Post office versus FedEx. It's important for NASA to retain their own launch capability, just like we have the post office, and the post office has redundant architecture to FedEx or UPS or DHL, right? Why do we have the post office when FedEx can do all that? Well, we have the post office because the post office brings stuff to the table that you don't get from FedEx or from UPS. They do have a lot of overlap, but they are two different entities. You can't go to the FedEx and like get a passport or whatever. You know what I mean? Like, well, that's not really how that works, but you get the idea. NASA, in regards to that, should have their own domestic launch capability that is completely dissimilar from commercial. Just like the mailman drives a different truck around than the UPS driver or the Amazon driver or the FedEx driver. You know what I mean? Now that's imperative. That's another key to sustainability. You have to have NASA there as a baseline. I don't want governments just launching stuff into space, but I don't want commercial corporations just launching stuff into space either. And once again, I use the post office as a very, very, very good example of why. $2,042 men and 105 pieces of equipment are used. Cool. Chris, 59-month resub. It's a video congratulating... Oh, Builders Day. Got it. Post office has actually been picking up the word, and FedEx and UPS do not want to, i.e. houses in the middle of nowhere. It offers a service that FedEx and UPS can't. That's why we still have the post office, even though it's redundant in many ways to FedEx and UPS. It also, I mean, there's some folks out there that are critical of the post office and say it's a waste of money. But there are also people out there that say NASA is a waste of money. You're very familiar with those guys. We know who those people are. Commercial can do it better. I do not think that there's a sustainable way forward if we don't have NASA and so a government program and a private program operating in conjunction with each other. There's no sustainability there. That will lead to stagnation. Once again, it feeds back to my unifying theory. Less rockets is bad for pushing to make life multiplanetary, for instance, or for the market. It's bad. That's a very bad thing. This is Angara, it is. Levy, what did you say up there? To be honest, I've been thinking of stuff like demand by looking at examples in the aviation industry. The A380 is an interesting case of something being just too big, but still meeting some of the degree of success. There's still a huge loss in Airbus's books, whereas the 787, A350 are winning out by having more efficient. Well, yeah, I mean, you can predict demand, but you don't, like, sometimes that's unknown unknowns, Lavi, you know? 747 was only supposed to be an interim design that was supposed to only last 10 years before we moved to supersonic transport. They ended up making it for 50, right? How do you prevent Kessler syndrome with this new market that's only expanding? I'm seriously scared of this. Well, if Starship can go up there and we pursue reusable technology, man, see, we could just go and get the debris before it causes any problems. Decommissioning satellites means, you have to go and get it. And that's something that NASA could provide as a service that's not generally profitable, but a service that we need to keep the waters clean, so to speak. Just like the EPA and super funds, are designed to clean up industrial pollution, right? That's what I mean about NASA working in conjunction. NASA can be there as a safety valve for deorbiting old satellites. It's a technology that we need, but it's a technology that's not necessarily profitable. I'm pretty sure that's what NASA's supposed to do. Pioneer technologies that aren't profitable so they become profitable. Do all the development, do all the dirty work. That's what NASA's supposed to do. This is what I mean. NASA needs to exist. They need to exist, and they need to have their own domestic in-house launch capability on top of commercial working in conjunction with it. We're heading for either stagnation or disaster if we don't do that. There's no, dude, I weigh this every night. This stuff keeps me up. Manzi, just like Kessler syndrome keeps you up, this stuff keeps me up at night. That's the only way forward. The U.S. is always going to have the minimum need for military launches, so government involvement can't really go away. Bingo. Yeah, Exaris, there's also that too, but yeah. Talking about more satellites. Here, let's watch this footage. Pretty much now, King. Alright, so propellant depot there. He's a base. Nobody knows. Yep, see? They're putting sealant on this. All this stuff is going to be buried underground. So, once again, if you're looking like, whoa, what are they building here? This is a launch complex. What the Russians do, because they can, because we can't really do this in Florida, they build all the GSE into the pad. They build it into the ground, because the ground is the best way to not have the rocket destroy the launch pad, right? So all the equipment and all the everything, all the equipment, not necessarily propellant depots, but all the electronics, all the ground support equipment, all the GSE is built underground to basically shield it in case, something bad happens. Or it's built inside of basically an armored box. The Russians put all the GSE in the ground. We don't do that in Florida, for instance. We raise the pad up and we build it on basically a graded, raised mesa. All right, and we have to dig a retention pond in Florida, or else if you built the pad just on the ground, it'll just sink. So we can't build down into the ground. But that's what the Russians can do that with the soil that they have over there. We don't necessarily, we can't necessarily do that in Florida. So we build up, they build down. Well, the pad, this is all the GSE. The rocket's going to be where my mouse cursor is. That's where it's going to launch from. See right there? This is the longest 6 p.m. Eastern I've ever seen. All right, fine. Screw the rest of the space news. Let's play Kerbal. The words in the song are cosmonauts are dreaming about the apple trees blooming on Mars. Me too. Okay, two to three more things. So Sierra Space is posting this. This is a picture of their Shooting Star attachment module for Dream Chaser. This is a service module for the Dream Chaser spacecraft that will dock with the ISS. The Dream Chaser will be attached to the front of it, but it looks like they have the common berthing mechanism built out on the back. The Shooting Star, once again, is a conic adapter. It literally looks like a cone. And on the back, they have a module that similar to the forward docking port on Cygnus or Dragon 1. And then on the back, they have a docking module that's similar to Dragon 2's docking module called an IDSS. The IDSS is going to be attached to Dream Chaser. And Shooting Star here is basically going to be a service module to allow Dream Chaser, which is a shuttle, to stay on orbit for long periods of time. Shooting Star is actually pretty cool. It could serve as an adapter for more vehicles to be able to dock to the station that use IDSS in the future, or you could use it as a mini space station. Or you could just use it as a service module. There's some pictures of the first one coming from Sierra Space right there. Shooting Star is this thing in the back. See that? It's a service module for a shuttle, for Dream Chaser. Sierra Space is working on this for the commercial resupply program. NASA gave them a contract for resupplying the space station, along with Dragon cargo in Cygnus. Dragon 2 cargo. There's a picture of the Dream Chaser. And then there's a picture of the ring for the CBM. They usually post cool pictures of stuff here on their account. Yeah, check that out. Hey, that's pretty good. What is that, solar? This is our offloader, the deployment fixture that simulates zero gravity so we can deploy our solar panels for Dream Chaser for testing. Yeah, that's cool. Yeah, there it is. That's the flight. That's a flight test article. But yeah, first flight next year. At least that's the idea. One more. It's Prichel. Yes. Yeah, I didn't cover this yesterday. Let's go over here like this. Cargo ship Progress MUM with a nodal. Yeah, there's Prichel. Prichel was delivered to Baikonur. That's the next ISS module to be attached. It should be attached at the end by the end of this year. It's a multi-port. It's a multi-axis docking node, which is really cool. And it'll dock to the bottom of Nauka. There's its service module. It's basically a Progress service module with an adapter, and Prichel is going to be on the top. No cargo module and no orbital module. The Soyuz, they basically put the space station module on front and put the service module on the back. Common service module, which is really cool. It's a really smart design. How did the original Dream Chaser proposal flying on Atlas V remain aerodynamically stable without a payload fairing your wings at the back? RD-180s have 8 degrees of gimbal. That's the reason. It can stay pretty safe in that regard. The formation of the Marathon Communications Satellite Constellation will be fully completed in 2027. The first Marathon runner is planned to be launched in 2023. In total, the constellation will include 264 satellites located in 12 orbital planes at an altitude of 750 kilometers. What's Marathon supposed to be, guys? Kem Vasi, what's a marathon? What's the marathon thing supposed to be? Probably similar to OneWeb or Starlink. Interesting. All right, sweet. So, okay. And then last little bit of Starship news. Booster 4 and SN20 or Ship 20 are back in the high bay. Or they're back at the build site to finish, to be completed to their final prototype form when they go to launch, whenever that may be. They have most of the tiles installed on 20 there. You can see that they've added more since.